Okay, it's Mr. Robs here. We're working on a second puzzle on set 1 for quadratic functions. And I'm given f of x is equal to x minus 4 squared plus 1. This, if I look over here, is not standard form. It is not standard form. It is another form. This is what we call vertex form. Okay, and if we think about what vertex form looks like from way back here, we can see that it was vertex form here. Okay, so let us continue with this vertex form. But if I want to get it to standard form, it means I just have to multiply all this out. I know that this is going to be x minus 4 times x minus 4 plus 1. So if I multiply that, I get x squared minus 4x minus 4 more x is minus 8x plus 16 plus 1. So x squared minus 8x plus 17. So standard form is f of x equals x squared minus 8x plus 17. And so a is 1, the number in front of x squared, b is negative 8, and c is 17. Okay, and so if I'm going to graph this, I'm going to go over to Desmos to help me out a little bit. I'm going to work on this part first, and I'll add the plus 1 after. So I have x minus a, and I start with a being 0, so that means I just have x squared, which is our first parabola. When I make changes to x minus 1, I'm going to make a 1. Take a moment, predict what you think is going to happen. And then when I do it, when I make it 1, put it over here. X minus 1 moved it over to plus 1. So if I make it x minus 2, it's over at a positive 2. And so on. So the reason why that happens is because when I have it over here, if I have y equals x squared here, I'm saying that if I put in 2 here, if it's 2 minus 2, if it's 2 minus 2, it means it acts like 0. It acts like if x is 0. So it's making only 2 will make the 0. So 2, a positive 2, will make the y value 0. So if I'm going to make this 4, then it's going to go a positive 4, because only a positive 4 will make this 0. So I know now, one thing I know from my graph here, let me do a different line here. From my graph, when I make my axis, I know that this means I'm going to move over 1, 2, 3, down here is 4. I'm going to move over 4, and it's going to be going upwards like this because there's no reflection. Now let's do the plus 1. If I just do the plus 1 now, if I take it, and I take it, here it is here, my vertex at 4, 0. If I add plus 1, it moves it up 1. And so this here, negative 4 plus 1, means the vertex is opposite of this one, positive 4, positive 1. And so my final graph goes up 1 here, and I get this nice parabola here where my vertex is 4, 1. And so when I do my key features, if I look at my key features here, I know it's the vertical a value equals 1. Okay, I know that my vertex is 4, 1. I know my axis of symmetry, well, it goes through here at x equal to 4, which is the x value of the vertex. My x-intercept, well, that's a bit of a trick because there is no x-intercept. None, because it does not cross. My y-intercept, to find the y-intercept, I know I must make the x value 0. So let's actually make the table. I'll do my table. I get x, I get f of x. And let's, I don't know, let's do -1, 0, 1, 2, 3, and 4. So if I plug -1 into here, -1 minus 4 is -5. Squared is 25, plus 1 is 6. 26. If I put 0 in here, 0 minus 4 is -4. Squared is 16 positive. Positive 16 plus 1 is 17. This here is my y-intercept because x is 0. So 0, comma 17. And so if you're not sure, I'm doing f at 0, which is 0 minus 4 squared plus 1, which is 16 plus 1, which is the 17. I go on to 1, 1 minus 4, so f at 1 equals 1 minus 4 squared plus 1. Well, that's minus 3 squared plus 1, which is 9 plus 1, which is 10. 2 minus 4 is -2. Square that is 4, plus 1 is 5. 3 minus 4 is -1. Squared is 1, plus 1 is 2. So 3, 2. I also know I can go over 2, which is 2, and I go up 4 from here. So over 2, up 4, so that's going to be up to the height of 5, which is true. 4, I already know what 4 is going to be. 4 minus 4 is 0 squared. I get 1, which is my vertex. If I do 5, from here I go over 1, up 1, which is 5. It's going to be 2 here, and so on. And so if I go 6, it's going to be 5, and the pattern continues onward. F at 7, well, f at 7 is going to be 7 minus 4 squared plus 1, which is minus 3 squared plus 1. That's 9 plus 1 is 10. Okay, continuing with our key features, let's see what else we have to put on there. We revert to x and y-intercept, just the domain and the range now. So my domain, thinking about my vertical lines here, here's my vertical lines. And if I think about it, wherever I take this curve here, it will eventually touch the graph everywhere. And so x belongs to real numbers. And then if I do the other line though, the vertical line, the horizontal line, well, then I can see no, 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 yes, 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 yes. So, no, 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 no. And the yes is when it touches, and no when it does not touch. So here it starts to touch, and that is coming from my y value, the vertex. Y can be bigger than or equal to +1. Okay, and so I've done the graph, the table, and the key features. It's in standard form here and vertex form here. So if I think about the transformations here, is it reflected over the x-axis? No. Vertical stretch? No. Shifted up? It has been shifted up by 1 unit. And I can see that right here is my shift up. And similarly, it has been shifted to the right by 4 units. The right by 4 units. And I can see that here because it's in the opposite direction of the sign. All right, so now, solving this problem, I know f of x is equal to x minus 4 squared plus 1 is equal to -6. Well, x minus 4 squared is equal to -7 when I subtract it over, and I square root both sides, and uh-oh, this cannot happen, therefore there is no solution. So what this says, if I put on a line, I have my graph here, here's 4, 1, here's my parabola. If I add this line, f of x equals -6, that's down here. Of course there's no solution. They do not intersect. All right, so no solution. All right, so here is another puzzle for you. It's more complicated, there's more bits involved. Good luck.